Welcome to ISINTC, IT Infrastructure and Network Technologies. Module 1, Basic Network Concepts. A network is consist of two or more entities or objects sharing resources and information. A computer network consists of two or more computing devices connected to each other to share resources and information. The network becomes a powerful tool when computers communicate and share resources with other computers on the same network or entirely distinct networks. Computers on a network can act as a client or a server. A client is a computer that requests for resources. A server is a computer that controls and provides access to resources. Data is a piece of information. The computing concept hierarchy of data is used when planning a network. It is essential to maintain a hierarchy of data to manage and control resources among computers. Network access to data must be evaluated carefully to avoid security issues. Communications and telecommunications. Communications is an activity associated with distributing or exchanging of information, while telecommunications is a technology of communications at a distance that permits information to be created anywhere and used everywhere with little delay. Today, it involves data, voice, and video. Data refers to digital and analog. Voice refers to spoken word. And video refers to telecommunication imaging. Node. Anything connected to the network. It is usually a computer, but it could be a printer or a scanner. A node is any physical device within a network of other tools that's able to send, receive, or forward information. A personal computer is the most common node. It's called the computer node or internet node. Modems, switches, hubs, bridges, servers, and printers are also nodes, as are other devices that connect over Wi-Fi or Ethernet. For example, a network connecting 3 computers and 1 printer, along with 2 or more wireless devices, which has a total of 6 nodes. Segment. Any portion of a network that is separated by a switch, bridge, or a router from another part of a network. A network segment is a portion of a computer network. The nature and extent of a segment depends on the nature of the network and the device or devices used to interconnect end stations. A network segment is an electrical connection between network devices using a shared medium. Backbone. The main cabling of a network that all of the segments connect to. Usually, the backbone is capable of carrying more information than the individual segments. A backbone or core network is a part of a computer network which interconnects networks, providing a path for the exchange of information between different LANs or sub-networks. A backbone can tie together diverse networks in the same building, in different buildings, in a campus environment, or over wide area networks. Topology. The way each node is physically connected to the network. Network topology is the arrangement of the elements, like links and nodes, of a communication network. Network topology can be used to define or describe the arrangement of various types of telecommunication networks, including command and control radio networks. Network topology is the topological structure of a network and may be depicted physically or logically. Bandwidth. Bandwidth is the maximum rate of data transfer across a given path. Bandwidth may be characterized as a network bandwidth, data bandwidth, or digital bandwidth. Essentials for communications. It must have a message. Message must have a transmitter. Message must have a medium. Message must be understood. And message must have some level of security. Message refers to information or data to be communicated. That could be in a form of text, numbers, pictures, or video. While the sender could refer to the device that sends the data message, that is in a form of computer, video, or camera. And of course, the receiver. The receiver could be the device that receives the message. It could also be in a form of a computer, workstation, or television. Transmitter refers to the modem. The transmission or the transmission system refers to the public or telephone network. The receiver could be in a form of a modem, and the destination can be in a form of a server. Need for networks. Enhance communication, share resources, and facilitate centralized management. When using a network, people can communicate efficiently with a group of people through instant messaging, video conferencing, social media, chat rooms, etc. It is easy to share files, data, and information. Enhance communication. Computer networks use electronic mail or email as the choice for most of the communication. By using networks, information can be sent to a larger audience in an extremely fast and efficient manner. Share resources. A copy of data or application stored at a single central location is shared over a network. Computer peripheral devices referred to as additional components that can be attached to a computer and be shared in a network. Peripheral devices include faxes, modems, scanners, plotters, and any other device that connects to the computers. Equipments having common requirements can be shared in order to reduce maintenance cost. Important data can also be stored centrally to make it accessible to users, thereby saving storage space on individual computers. Computer applications which take up a considerable amount of storage space can be installed centrally on the network, saving storage space. Facilitate centralized management. Networks are used to assist in management tasks associated with their own operation and maintenance. Using network results in increased efficiency and a resultant reduction in maintenance cost. Software can be installed at a central location using servers, where the installation files are made accessible over the network. Classification of networks. So networks can be classified in terms of network geography and component roles. Classification by network geography. Networks are frequently classified according to the geographical boundaries spanned by the network itself. It can be in a form of LAN or local area network, WAN or wide area network, and MAN, metropolitan area network. And these are the basic types of classification, of which LAN and WAN are frequently used. So a LAN covers a relatively small area such as a classroom, school, or a single building. LANs are inexpensive to install and also provide higher speeds. So this is an example of a LAN connection. Classification by network geography. So we make use of these different tools. We have your Wi-Fi or the wireless fidelity. We have your access point. We have your ESSID or extended service set ID and your hotspot. Your Wi-Fi is a wireless technology that connects computers without cables. Access point is a device or base station that connects wireless devices together, usually connected to a wired network. ESSID is a name for the access point. For example, CAMC Wi-Fi. And the last one, we have the hotspot. It is the area covered by wireless access points. We have the MAN, or Metropolitan Area Network. A MAN spans the distance of a typical metropolitan city. The cost of installation and operation is higher. MANs are used in high-speed connections such as fiber optics to achieve higher speeds. We also have the different standards of connection. So we have the 802.11b, which can carry 11 megabit per second, 802.11g, which also can carry 54 Mbps under the 2.4G. And we also have the 802.11a, which also can carry 54 Mbps under 5G. In terms of security, we are using the WEP and WPA. WEP, or Wired Equivalent Privacy, is a security algorithm for IEEE 802.11 wireless networks. Introduced as part of the original 802.11 standard ratified in 1997, its intention was to provide data confidentiality comparable to that of a traditional wired network. Wi-Fi Protected Access and Wi-Fi Protected Access 2 and Wi-Fi Protected Access 3 are the three security and security certification programs developed by the Wi-Fi Alliance to secure wireless computer networks. War driving. It is, literally speaking, refers to hackers driving around with laptops or mobile devices connected to high-powered antennas, scanning for unlocked or no password needed for access or poorly protected networks. This is an example of a MAN connection. Wide area network. WANs span a larger area than a single city. WAN uses long-distance telecommunication networks for connection, thereby increasing the cost. The internet is a good example of a WAN. This is an example of a WAN connection. Classification by component roles. Networks can also be classified according to the roles that the network computers play in the network's operation. Peer-to-peer, server-based, and client-based are the types of roles into which networks are classified. Peer-to-peer. In a peer-to-peer network, all computers are considered equal. Each computer controls its own information and is capable of functioning as either a client or a server depending upon the requirement. Peer-to-peer networks are inexpensive and easy to install. They are popular as home networks and for use in small companies. Most operating systems come with built-in peer-to-peer networking capability. The maximum number of peers that can operate on a peer-to-peer network is 10. Each peer shares resources and allows others open access to them. Peer-to-peer networks become difficult to manage when more security is added to resources, since the users control their security by password protecting shares. Shares can be document folders, printers, peripherals, and any other resource that they control on their computers. So this is an example of a peer-to-peer connection. Next, we have the server-based. A server-based network offers centralized control and is designed to secure operations. In a server-based network, a dedicated server controls the network. A dedicated server is one that services the network by storing data, applications, resources, and also provides access to resources required by the client. These servers can also control the network security from one centralized location or share it with other specially configured servers. So this is an example of a server-based network. Client-based. Client-based network servers process requests from clients and return just the results. These networks take advantage of the powerful processing capabilities of both the client and the server. Application servers and communication servers are examples of client-based networks. So this is an example of a client-based network.